Welcome to 9.6. We're talking one-step equations involving multiplication and division of fractions. A little review. To multiply fractions, you simply multiply the numerators and denominators straight across. The biggest misconception is that you're cross-multiplying. We're overgeneralizing when we say that. Do not cross-multiply. You're multiplying across. 4 times 6 equals 24. 3 times 5 equals 15. And as always, simplify is the very last step. Every time you hear that dirty F word of fractions, you simplify. So I'm going to do the double mountain method today. So I'm going to find my factors of both values. 1 times 15 is 15. It's not even, so 2 is not in it. 3 times 5, I know because 1 plus 5 is 6. 6 is divisible by 3. 4 doesn't go in because it's not even. 5 is on the other side. Or again, to find your factors, use your calculator. 1 and the number always are present. 24 divided by 2, I get a whole number. It's a calculator moment right there. 24 divided by 3, I get a whole number. 24 divided by 4, I get a whole number. 24 divided by 5, I get a decimal. 6 is next, so I have it. Find the biggest number going from left to right that they both have in common. In this case, it is 3. That's what I'm going to divide, top and bottom. If you don't divide top and bottom, you are not simplifying correctly. You will change the value of the fraction. 24 divided by 3 is 8. 15 divided by 3 is 5. I will accept improper fractions as answers, although for those of you that want to challenge yourself, 5 goes into 8 one time with a remainder of 3. So as a mixed number, it would be 1 3/5. Either answer is perfectly acceptable. Dividing fractions. I always like to say when it comes to math, you don't want to reinvent the wheel. Take something you know how to do well and turn a new problem into that skill. So we're going to turn division into multiplication. 3 things to remember. Keep it, change it, flip it. What that means, we're going to keep the first fraction as is. 8/12 remains 8/12. We change it. Change from division to multiplication. Flip it. We're going to take the reciprocal of 2/3. The reciprocal is just a fancy $1,000,000 word for flipping it. 3 and 2 becomes 2/3. The last step in division is just simply multiplying. We turned it into a multiplication problem. As we know, to multiply, you multiply your numerators, multiply your denominators, and simplify. So, 8 times 2, 16. 12 times 3, 36. This time I'm going to do single mountain. I'm just going to find the factors of the smaller value. 1 times 16 is 16. 16 divided by 2 gives me a whole number, 8. 16 divided by 3, decimal. 16 divided by 4 gives me a whole number, 4. And then I check on my calculator. 36 divided by 16, decimal. 36 divided by 8, decimal. 36 divided by 4 gives me 9. As soon as I get a whole number, I know I'm done. I'm going to divide top and bottom by 4. 16 divided by 4 equals 4. 36 divided by 4 equals 9. Always simplify with fractions, whether you're just evaluating like this or solving in one-step or eventually two-step equations. Let's try a couple together. 3 times 2 will give me 6. 16 times 4, 64. Always simplify. Take the smallest value, 1 and 6. I'm going to use single mountain method. 6 divided by 2 gives me 3. 3 by my next number. 64 divided by 6 does not work. 64 divided by 3 does not work. 64 divided by 2 gives me a whole number, not a decimal. Divide by 2, divide by 2. 6 divided by 2 gives me 3. 64 divided by 2 gives me 32. I know my answer is simplified because I found all of my factors. Remember, with division, you keep it, change it, flip it. If the negative is out front, assume it's going in the numerator. It's easier just assuming that it goes in the numerator. Value-wise, I did not change anything. I just assumed that instead of the whole value being negative, I have negative 6 divided by positive 9, which would give me a negative answer. Keep it, change it to multiplication, flip it to the reciprocal. A little tip: if you want to simplify beforehand, you can only do this with multiplication, or in the case of division, that you've already turned into multiplication. If you keep in mind your factors. Now, I could just do negative 6 times 18 over 9 times 4, but I'd end up with big numbers to simplify. I know off the top of my head that 9 is one set of 9, 18 is two sets of 9. I'm going to just get rid of those values. I simplified them across. Now I can deal with negative 6 times 2 to give me negative 12. 1 times 4 is still 4. Just because I simplified beforehand, I do not want to assume that I'm done simplifying. Take the factors of the smallest number, 1 and 4. 2 times 2. 12 divided by 4. Oops, that gives me a whole number. So I'm going to divide top by 4, bottom by 4. Negative 12 divided by 4 is negative 3. 4 divided by 4 is 1. Now, negative 3 over 1, you could leave that as your answer. I would also accept negative 3, since they are, in fact, the same. And we'll discuss that again in a moment. On your own, try these two problems. Show all of your work for credit, pause the video, and come back when you're done. Welcome back. Answer to number 1 will be 6/5. If you are challenging yourself and simplifying down to mixed numbers, 5 goes into 6 one time with 1 left over. 1 is my remainder. So I'd also accept 1 and 1/5. The answer to the second problem ends up being 4 over 27. Multiplication and division do the exact opposite of one another. They are inverse operations. So if the answer to the first question, what's happening to my variable, is multiplication, the answer to my second question, how do I undo it, is division. Let's look at a couple of equations. What is happening to my variable? Always ask that question. What is happening to my variable? We are multiplying. So to undo it, we divide. We know that to divide, we have to multiply by the reciprocal. So I'm multiplying by negative 2/3, so I need to divide by negative 2/3. In order to divide by negative 2/3, I'm really going to multiply by its reciprocal, 3/2. Again, keep that negative in place. Multiply both sides by negative 3/2. I get my identity whenever I use multiplication division. Likewise, if I tried multiplying this, 2 times 3 is 6. 3 times 2 is 6. The negatives cancel out. So I end up with x equals, and I'm going to look. I'm going to move my fraction up so I can look at it a little bit closer. Sometimes it's easier to see the fractions when they're next to each other. 5 times negative 3 is negative 15. 6 times 2 is 12. I can simplify that. Take the factors of 12, single mountain method, 2 times 6, 3 times 4, and I'm on the other side. 15 divided by 12, decimal. 15 divided by 6, decimal. Decimal, whole number. Divide top by 3, bottom by 3. So my final solution, my final answer, x equals negative 5 over 4. Again, if you are challenging yourself, I would also accept x equals negative 1 1/4. Now the next problem we're going to look at, you may see fractions written this way. 5x over 7. That's the same as saying 5/7 times x. So what are we doing? We are multiplying by 5/7. How do we do multiplication? We divide by 5/7. So again, to divide, I'm going to multiply by the reciprocal. Fractions are a great way to look at the identity. 5 times 7 is 35. 7 times 5 is 35. I'm left with 1x. 35 divided by 35 is 1. 7 over 5 times 2 over 9. 7/5 times 2 9ths. You need to do it to both sides. Keep things balanced. 7 times 2 is 14. 5 times 9 is 45. Always check if you can simplify. Never assume. You know what happens when you assume? You do poorly on your tests and quizzes. 14. 2 goes into 14 7 times. 14 divided by 3, decimal. Divided by 4, decimal. 5, decimal. 6, decimal. Oh my gosh, Windows. I do not want to change the color scheme. So, I don't see any factors. 45 divided by 14, decimal. 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 We know by definition when the greatest common factor is 1, it's already in simplest terms. To reiterate a point that we kind of fell upon earlier, a whole number can be turned into a fraction. You just need to write the whole number as your numerator and 1 as the denominator. This comes in handy if you have to divide a fraction by a whole number. You want to deal, whether you're adding, subtracting, multiplying, or dividing fractions by whole numbers, you want to turn them into fractions. Play on the same turf. On your own, try these two problems, pause the video, and come back when you're done. Show all your work for full credit. Welcome back. Solution number 1, it should come out to be x equals 1/2. Solution for number 2, we're going to walk through, because again, it looks confusing. This is a problem where you could ultimately cross multiply, or you look at it as 3/12. So I'm going to multiply by 12 over 3. This is the same as saying 3/12 times x. Multiply by the reciprocal on this side, 12 over 3. The 12's cancel, the 3's cancel. I get my identity of 1 on the right side. X is by itself. Remember, pro tip, if you want to look for factors first, 12 and 4, well, I know they share a common factor. This is 1 set of 4. This is 3 sets of 4. I just made my multiplication values a little bit smaller. I have smaller products now. 3 times 7 is 21. 3 times 1 is 3. I'm not even going to do my mountain because I know that 21 divided by 3 automatically becomes 7. It's okay if it becomes a whole number. So my solution is 7. If you wanted to, you could plug it back in and check. 3 times 7 would give me 21 over 12. Now, even though this doesn't look like a true statement, if I simplified 21 over 12, I would get 7/4. They have a greatest common factor of 3. If I divide top by 3 and bottom by 3, I would get the same exact fraction. A good way to check your work. We just covered one-step equations involving fractions, specifically with multiplication and division today. On a scale of 1 to 5, rank how well we hit our target. If you don't feel the target was hit, make sure that you ask questions either during practice tomorrow or during the Fast and Studious. Thanks for coming by, and I will see you in class.